Good morning, all of you, and a warm welcome to yet another episode of Young Science Leader Series. Today with us, Dr. Manjesh K. Singh. He's a faculty assistant professor in the Department of Mechanical Engineering at IIT Kanpur. So, Dr. Manjesh is not only a keen faculty in mechanical engineering, he's also a runner. So, I have shared his pick, running pick. So, he did his postdoc from Max Planck Institute in Mainz in Germany and a PhD from ETH Zurich, Switzerland. ETH is, friends, it's one of the very well-known institute. It's the same place where Albert Einstein worked. And a mechanical engineering ME from IISc Bangalore, and he holds BE, Bachelor of Engineering from IEST in Shibpur. And his research area are soft matter, tribology, and rheology, the two fields I've never heard of. So I'm really excited to hear your talk, Dr. Manjesh, tribology and rheology. So I hope you will introduce these two fields and also discuss a bit about the opportunities in this field, research as well as career. And he's also a life member of the Tribology Society of India. So please join me to welcome Dr. Manjesh. And today with me, a co-moderator of this session is Naumika. Miss Naumika is daughter of Professor Padma from KSRCAS. She was with us as a co-moderator in our last week's episode. So I'm really happy to welcome you, Miss Naumika. She is actually a student at Anna University Regional Campus in Tirunelveli, the place very well known for halwa. And she's doing remote sensing and geoinformatics BE second year. Over to you, Miss Naumika.
Greetings, everyone. I'm Naumika. I'm currently pursuing my undergraduate in the field of geoinformatics from one of the regional campuses of Anna University. And my interest is towards space, and my ambition is to be a part of the planetary exploration missions in future. And now we have Dr. Manjesh K. Singh to begin a spark in us to have a career in science. Over to you, sir.
Thanks a lot. Thanks a lot once again, Naumika, for a nice introduction, and thanks to Felix and Nitin for the opportunity. So I'll share my screen. Let me know if you can. Okay, just a minute. Okay, is my screen visible to all of you? Hello?
Yes, please go ahead.
So, thanks once again, as I said, for the opportunity. So, as mentioned, I am currently at Department of Mechanical Engineering, IIT Kanpur. And I have my academic profile once again. So, I am currently working as assistant professor in Department of Mechanical Engineering, IIT Kanpur. Before that, I was in MPIP Mainz, Germany. Before that, I did my PhD from ETH Zurich in Department of Materials. My Master's of Engineering is in Materials Engineering, IISc Bangalore. My Bachelor is in Mechanical Engineering from IISc Shibpur. At our time, it was called Bengal Engineering and Science University, Shibpur. People better known, it's better known, or people know it as B College, Shibpur. So it is one of the oldest engineering college in India. My research interests soft matter, tribology, and rheology. So I will tell you a bit about soft matter and tribology. And I didn't prepare any slide because I normally get to ask about tribology, what is it? So I have a couple of slides about tribology. And my research experience is like I do both simulation and experiment at every state, master, PhD, postdoc. I have always been doing 50-50. So both continuum and MD simulations. On experimental side, tribometer, AFM, and electrospinning. I will not be giving very technical talk. I'll just tell you the kind of problems I solved the scientific problem I had at my hand, or I was given to solve during my PhD, postdoc, and masters. So here with this, I'll start. So first of all, what is soft matter? So I should have rather kept tribology and rheology, but I have soft matter and tribology in my presentation. So soft means normally low energy density, which is nothing but low modulus. So, I mean, we have a sense of what we call or what do we mean by soft matter. But if you go from scientific definition point of view, then these are materials which are characterized with low energy density, nanoscopic length scales, large conformational fluctuations, so large intramolecular entropy. These are all like and then the relevant thermal energy is scale is kBT. So kB is Boltzmann constant and temperature T. This is all, I mean, technical thing. But for example, if I have to cite some examples, this polymer, colloids, liquid crystals. I mean, there are all sorts of materials. Our body is made of soft materials. And with this, I will move to main part, I mean, main topic, which I would like you to tell about tribology. So tribology consists of two Greek words. Tribos means rubbing and logos means logic or principle. So what we study in tribology is the science and technology of interacting surfaces in relative motion and related subjects. So if I have to tell, or I mean, if I have to pinpoint a few topics which we study in tribology, it's friction and adhesion, lubricant and lubrications, wear and its mechanism. So this all together comes under this topic or subject called tribology. Tribology is not very, I mean, I think this term itself was I mean, suggested, I think in 1964 or 66 by a British scientist called Jost. And so what its application, so it's all around us. I mean, so we are surrounded with the tribological systems. So you have different kind of system. There are things where you want minimum friction and minimum wear, like bearings, gears, cams. You don't want very high friction and high wear. But there are systems where you want minimum wear but maximum friction, like brakes, clutches, clamps, tires, shoes. I mean, when you're walking, you want high friction but no wear. So these are the I mean, applications where you want to have friction maximum because you have to transmit the energy in case of brakes or clutches, but you don't want high wear because otherwise you have to keep on changing your brakes or your clutches. Then you have system. We have cases where we want maximum wear and maximum friction, like erasers. When you are erasing something when you're writing something with pencil and you're erasing, you want both high friction and high wear, otherwise it will not work. And then there are cases where we want minimum friction but maximum wear, like pencil. When you're writing with pencil, you don't want very high friction, otherwise it will be very noisy. But you want very high wear, otherwise you cannot write it on the or put it whatever you want on the paper. So these are some of the applications. I mean, we are all surrounded by tribological society. Anything which is moving relative to other things, they have tribology there. Why is it important? Because tribological deficiencies, I mean, large amount of energy and material losses occur because of tribological deficiency. So if you want to save energy or material, tribology is a subject which is, I mean, which we need to understand in terms of numbers. So there's various studies estimate that approximately 1% of GDP by application we can save roughly 1% of GDP by application of basic principles of tribology. So what are the things we can do? Primarily, like energy dissipated by friction. So there are like energy losses because of energy dissipated by friction. So we can reduce that if you control friction, and there are cases where you need friction, but you want to have optimum friction, not too high friction. And secondary, energy needed to fabricate replacements. If you have high wear, you have to replace the machine element or the material. So if you have good tribology, you'll have less wear. So you need less replacement. So you have to fabricate less of replacements. And tertiary, energy content of materials for replacement parts. With this, I hope I could tell you what tribology means and why we should study it. I mean, and with this, I will just move through my life and learnings. So I am basically raised in Calcutta. I mean, my name may suggest, and I'm not as such a Bengali. My family belongs to Bihar, but my grandfather moved to Calcutta for better livelihood. And since then, my family is based in Kolkata. So me, my father, we are all raised in Kolkata. In Kolkata, it's a big city. I was staying, or I grew up in a place very close to this, where we had this famous bridge collapse in Calcutta. My house was, I mean, roughly 200 meters apart from that place. So, I mean, by the time this thing happened, I was in France at that time in a conference when I got a BBC notification that there's a bridge collapse in Kolkata, and my family is now in the other side of Calcutta, that is Havra. Uh, Even that time we were already in Havra, but this is, I mean, this bridge or this area I used to cross at least 100 times in a day. So this is one of my picture of childhood where I am with my one of my cousin brother, elder brother. I have grown up in a semi, you can say semi joint family. My parents were not very educated, but I had in my family enough number of engineers. Like my uncles were engineers, so I got pretty good guidance. And my parents were motivated to give me and my siblings good education. So my early schooling is from Maheshwari Bhavan. It's in Calcutta. It's a Hindi medium school. So I'm a typical Hindi medium type guy. So all my early education is in Hindi medium school. For 11, 12, I moved to St. Lawrence High School. That is again in Calcutta. It is a very renowned school. So I had to transition from a Hindi medium education to an English medium system. I had quite good experience there. And then with this, I will move to my Bachelor of Engineering. And so I did at IIST Shibpur. It's better known as B College. It was established in 1856. So it is second oldest engineering college. And I have few snaps from there. So first of all, I would like to introduce my professor, Debasis Datta. So whatever I mean, I had no plan. I mean, before I entered Shipwood, I wanted to be an engineer, and the motivation was because my uncles were engineers, and I saw that they had a, I mean, or I would see around me that pretty much they are making, I mean, the engineers have good life. I mean, so that was the motivation with which I went for engineering. But then I saw my professors in Shipur, and then I got into this, almost in second year of my engineering, I decided that I'm not going for job, I will do masters. And I decided also the institute, I will tell you. And because of this, I also had to take a certain decision. So I decided that I'll do from IISc Bangalore my masters, and for PhD I would go abroad. And he has been the main inspiration who inspired me for. He never told me, but just attending his classes was good enough for me, and I'm still in touch with him. Whenever I'm in Calcutta, I make a point to meet him and discuss with him. And then also I met my better half there, Shoro Joy. She is also a faculty at IIM Raipur. So we are both in academia, but we are having right now long distance relation. And we are married since 2005. So at that time, this picture is from 2009 when I was in final year of my bachelor's. And this is, the first gate or like a gate through which we used to enter a campus. I have very good memory. And these are my batchmates or classmates there in the Shibpur. And one thing which I'll tell you every step I learned something. So one thing my professor, Professor Datta, he told me when I was going for masters, that be careful with your guide selection, because as you grow further, it's not the institute, your guide or your thesis advisor would matter a lot, because you have to be in contact with him, you will learn from him, his personality would have a lot of impact on you. So be careful with your guide selection. That's what I would also tell you. So that was my learning from my Shipwood. Apart from all the education which I got in engineering, that was the life lesson I got from my professor. Once he told me that be careful whenever you are choosing your guide, because it's one of the most important, it will have a lot of impact on your life. So with this, I moved to IISc, Masters of Engineering. And I got admission in materials engineering. As I said, I decided that I will go to IISc Bangalore as well. My rank was not good enough for mechanical, but I was very much that I will go to IISc only. So I decided to change my department, switch to materials. Luckily, it turned out to be good. I realized that materials has a lot more opportunity for research. So in IISc, again, I had two good advisors, Professor Vikram Jairam and Professor Sanjay Biswas. And they were both very different personalities. So Professor Vikram Jaram from materials engineering, Professor Sanjay Biswas from mechanical. So I mean, I still remember my interactions with them. I really met them together. So if whatever I do, I go to Professor Biswas. He will always treat me as a very young child. I mean, and I was youngest in the group as well. So he will, whatever I go and show him, and he'll say, wow, 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 you have done very good. You have done very good. He will explain to me that why I'm getting this and that. And then the same result, I'll go with Professor Vikram Jairam, and he will question me. And then I understood that, I mean, at that time, what I used to do, I'll go with my results first to Sanjay Biswas. He will tell me some things, and then I know that how to explain these results, and then I'll go to Professor Vikram Jairam and tell him that what all I understand from there. But I realized that I have to be my best critic. So whatever results I'll get, I have to analyze it, I have to understand, and I have to see from all sorts of like point. I mean, why I chose this speed or this velocity or this material or this system. I have to prepare, I have to be prepared to answer all those questions. And that lesson I got from Professor Vikram Jairam, that you have to be your best critic. And he also told me, and like I got one lesson from him when I was applying for PhD, and he asked me, where are you applying? And I told him certain places, and he told me, I mean, it was rather blunt, and that's how he is. So he told me, beggars cannot be choosers. So don't narrow down your options when you're applying. You first apply to places. Of course, you have to keep your financial constraint in mind, but apply to places. Once you have options, then you become choosy. Don't become choosy when you're applying beforehand. So that's one lesson which I have followed afterwards everywhere when I applied for PhD, postdoc, or even for the faculty positions. And ISU is also the place where I picked up running, thanks to my cousin Jayant, with whom you saw my picture before. He told me that, why don't you run? So I told him that I don't have time. He said, that is an excuse. If you want to do something, you find time. If you don't want to do something, you find excuse. So that is another lesson, that you have to, if you want to do something, you'll find time. If you don't want to do something, you find excuse. So time management is there, and you always manage time for things which you want to do. Again, all my batchmates and classmates from materials department in IISc during my Masters of Engineering. And with this, I will move to what I did there. So as I said, that my work or my research has been more into tribology. So like lubrication and friction control and wear. So my job there was to explore water as lubricant. We know water has some very good properties to be considered as a good candidate for lubrication. Like, it's readily available, it's non-toxic, so environmental friendly. It has high heat capacity, which gives it excellent heat transfer properties. But at the same time, the biggest problem with water, two of the biggest problem with water is, one, low boiling point. So it will boil most of when you do metal work or you do manufacturing processes, your temperature shoots up very high. I mean, much above the 100 degrees centigrade. So water will simply evaporate. And the biggest problem with, the biggest blockage in using water as lubrication is this low pressure viscosity index. So for any fluid, which are used as lubricant like oil and all, if you increase the pressure, its viscosity will go up. And that gives it the support. And this viscosity going up with pressure basically helps to support the normal load, whatever normal load you're applying, which will be supported because the viscosity goes up. And then the low shear, the low shear or low viscosity of, the low shear viscosity of this of the fluid in between a fluid film helps you to lubricate. So, but this is the problem with water. It has very low pressure viscosity index. So if you apply pressure, water cannot support normal. It will simply squeeze out and you have hard surface contact. That's why you don't see water being used as lubricant very commonly. I can tell you one application where still it is used, till last I knew, is mining industry, where you don't want to use oil for lubrication inside the mines with pumps and anything. That's why you use water, even though it's very high friction, very low efficient, but you don't want to use oil at all. So you go for water-based lubrication, or simply water, just water is lubrication. So what my task was to explore water as lubrication, and we wanted to replace oil. So there was this suggestion that we can use nanoparticles which have layered structures like graphene, like molybdenum disulfide, this HBN nanoseeds. So if you look at all these materials, within the plane, they have strong covalent bond, intraplane. Or interplane, they have weak van der Waal interaction. So if you apply shear, because of the weak van der Waal interaction, they'll shear easily, and it will give you low friction. So that's what we wanted to exploit to get together with water. So normally in lubrication, in metalworking, in rolling and all, we use oil in water emulsion. So what happens that you have oil droplets suspended in water, and when this emulsion goes into the contact zone, the water would squeeze out and oil will take care of the lubrication. We have more than 95 or 90, much more than 95% of water, and only 5%, even much less, I think up to 2% of oils. So this water takes care of lubrication, and oil and water, basically it takes away the heat generated. And the main role which water plays is that it will spread the oil droplets in the contact. So what we wanted to do was that we wanted to replace these oils, because oils are bad, for our environment. So we wanted to replace this oil with nanoparticles. As I said, these nanoparticles, not any random nanoparticles, the nanoparticles which I showed you before, those having layered structures which can shear easily. So we wanted to replace this oil with these nanoparticles. So that was my master thesis. I did both simulations and experiments. I'll not get into that. I'll just stop there. So with this, I moved to ETH in 2011 September. For first 4 or 5 months, I was there research assistant. And from 2012 February, I started my PhD there. And here are my two supervisors and co-supervisors. You can see them with me. So on the left is Professor Nicholas J. Spencer, and the right is Professor Martin Kruger. And from here onwards, I never worked with engineers. So Professor Spencer was a physical chemist. Professor Kruger, he's a computational and theoretical physicist. So, and so I worked thereafter I started to got into research also with very interdisciplinary people. So what I did there, I'll tell you later on. And there also I continued with my running. So for 5 years I was there. I used to run every year in an event which was like for 10 kilometers or something. And then I finally got my degree in 2016 January. My wife, she looks happier than me with my degree, and my colleagues at the laboratory for surface science and technology at ETH Zurich. And what I learned there with Professor Spencer was that he was very easygoing person. I had kind of a dream boss for PhD. I never had any hiccups, any problem. He never, I don't remember, not just me, if any of my colleague told me that he shouted at them. He's very renowned. He got the gold medal in tribology last year. So that is the biggest award you can get in the field of tribology. And he recently retired, and just yesterday one of my friends shared, he retired this year only, when because of this COVID, his farewell speech is postponed to next May. And there's an article on ETH website about him. And I like this line about what they've written. One thing is certain, Nicholas Spencer will never be bored. So, we had a very nice experience. He would organize for us tango classes and wine tasting, and he will take us to nice places every year for the offsite group meeting. We were very happy, and then at the same time, we were doing good research as well. At the end, I had 4 papers with him during my PhD. I got a good postdoc later on as well. And I never felt any pressure that I am doing PhD. Even some of my friends used to tell me, how come you're so relaxed? But it's all thanks to him. And I hope I picked few things from him, and my students will also not complain about me that I am pressurizing them for results. And then on the right, Professor Martin Kruger, he was my co-supervisor. one thing, he is basically a theoretician and computational physicist. So, I mean, I would write very long codes, and when I go to him, he will write the same code in maybe 1/4 of the space. So I mean, I learned from him being efficient with code writing. So now I'll tell you what I did in my PhD. So now I started to work with polymers. So I don't know, I mean, how many of you are from polymer background, but if you graft polymers from one end on a surface in a good solvent, in the grafting distance, this D0 is such that it's much higher than the radius of gyration or size of the individual chains, you'll find a mushroom-like structure. If you bring them closer in a good solvent, they will stretch out and form semi-stretch-like structure. And if you bring them further closer, they'll stretch out and form brush-like structure. And we call it polymer brushes. In our body, all the lubrication in nature is based on this only, this polymer brushes, and with water. So here also, I mean, you can use water as a lubricant with these polymer brushes if you have hydrophilic brushes, and you can use water as a lubricant because these brushes would support the normal load, and the low viscosity of water would give you extremely low coefficient of friction. Sometimes it's so low that we cannot even measure with any known tool. If you repeat the same thing in a bad solvent, you will get pancake cluster homogeneous layer. So this is just to tell you about polymer brushes, and my job was, polymer brushes has application in many fields. I mean, right from adhesion to like biocompatibility, and I mean, I've seen even in this during this COVID time, so people are grafting polymers on surfaces, and you have infection resistant surfaces for colloidal stabilization. But my job was basically towards lubrication. So we have in all our joints, even knee or any joints, we have this lubrication based on polymer brushes. Your contact lens, this is again nothing but a kind of polymer and water based lubrication. If you have high friction, that you will start bleeding, your eyes will start bleeding. So there also we have apparently hydrogels, like cross-linked polymers, which can absorb a lot of water, and you have very low friction. That is also based on this polymer brush like system. So as I said, it has application in our body. So this is what we have in our cartilage, this glycoproteins grafted on surfaces, and then synovial fluid in between helps you in the boundary lubrication. So I'll not get into details. So my basically job or my work there, my PhD work was to study the effect of different brush architecture, like length of polymers, grafting density. If you introduce cross-linking, if you introduce stiffer chain, what will happen to the tribological behavior? The friction will go up or go down. And I did both experiments and simulations. Simulations was molecular dynamics, and with experiments, I was doing atomic force microscopy based tribological experiments there. With this, I moved for my postdoc in 2016 to Max Planck Institute of Polymer Research, Mainz. And since both my master's and PhD work were in tribology, so I wanted to shift or move away from tribology and to try something new. So that's why I went to a group where nobody was doing tribology, and I didn't want to do tribology, to be frank, as well. So I went to MPIP. So I was with Professor Kurt Kramer. He is a very well-known theoretical and computational physicist, a polymer physicist. I mean, he's very big name there. And again, I made very good friends. The one thing which I liked about working in Europe, that I was in a big groups and people from all over the world. So I had cross-cultural interactions, and I think I'm more informed, I will not say better human being before going to India. I mean, I was also a good human being, but I mean, say more informed, and I am more, so to say, I do more respectable to others' view or others' point of view than what I was before I went to Europe. And this has been gradual in my career. So when I grew up in Calcutta, as I told you, I did my studies in a Hindi medium school. So my interaction was limited to people who were speaking Hindi all the time. When I moved to St. Lawrence and then further for my undergraduate, this was first time I started to interact people who were non-Hindi speaking, like people who were speaking whose mother tongue was Bengali. And it was also interesting. I learned a lot of things there, and then I moved to Bangalore, South India, and very different cultural things, and I got to learn. I mean, I evolved from Bengal to I met people from all over India there, and I learned a lot about South Indian food and everything, and I like it a lot. And then same when I went to ETH, I met people from all over the world, Australia, Europe, in different countries, US, Iran, all, you name it. And then same in Germany, I was in a big group full of Indians, Chinese, Germans, French, all over the world. And it was, I mean, it was a good learning experience, and I am more respectable to others' point of views because of the time I spent in Europe. So what I did in my postdoc, so normally, I mean, all of us know polymers are basically large macromolecules made of repeating units called monomers. So polymers can be synthetic like polyethylene, polystyrene, or biopolymers like RNA protein. So I will like to point out here that the physics of polymers are same, whether you take the synthetic polymers or you take biopolymers. So it's absolutely same. It is not much different. The chemistry is very different. And my work was basically more on physics side, as I was working with the physicists there. So as I said, polymers are like very common in our life, all over adhesive, carpeting, rubber, tire, paints, everywhere we have polymers. And now they're becoming a problem as well because they're using too much of it. But we cannot avoid it as well. There are certain applications where we need it. And the reason why it's very commonly used, or you see it all over, because it's very easy to process polymers into complex shapes. It's very easy to process them, but it's not possible. It's very challenging to process high molecular weight polymer. I'm getting a bit technical side, but just to introduce you, it's very difficult to very difficult to process high molecular weight polymers. The reason being, as you increase the molecular weight, the viscosity and relaxation time goes up, and it makes almost impossible to process polymers. And why the viscosity goes up is because of entanglements. What is entanglement? You can think of your noodles, or like here, spaghetti. If you try to pull out one of them, it will come out of an imaginary cylinder formed by all its neighbor. So that is entanglement. So it's a kind of topological constraint put by all the neighboring chains on the on this one individual spaghetti. Suppose you have only one spaghetti, you want to pull it out, it's very easy. But suppose you have something like this, you try to pull it out, you will have to put in more energy. And that is entanglement, and that's what, as you increase the molecular weight, you have more and more entanglements, and it becomes difficult to process the polymers. So why we need to process high molecular weight polymers? Because then we will have better mechanical properties like toughness, strength, and wear. And God knows, I mean, this is initial research. If we are successful, then we may have someday car bodies and many of the parts for in different applications, which are with metal or ceramics or alloys, we can make with polymers if we can process high molecular weight polymers. So that was my job. My work was to study disentangled polymers. So we wanted to get rid of entanglements and then study the polymers. So I did in the simulation, you basically take individual chains. As I was saying, you take individual spaghetti, you collapse it and then put it together. Then you start from a disentangled state. So that was my simulation works, where I started my simulation system, and then we will study its relaxation and all, which I'll not show you here. And then again, in experiments, we did electrospinning at very ultra low concentration. And then you form this on the right most bottom right, the single chain nanoparticles. Again, you have them. If you have single chain collapse, then you have no entanglements. So that was basically my experiment and simulation system. And then we did different studies there on rheology and glass transition and everything, mechanical properties, but I'll not get into that. With this, I'll move to my next progress or part of my career, or next move in my career. I started as an assistant professor in mechanical engineering department at IIT Kanpur on 16 September 2019. So in another 11 days, I will be completing my 1 year here. Out of that, 6 months gone into pandemic. And so I have now a research group. So my research group's name is Soft Matter and Tribology Group. That's why I told you about soft matter and tribology in the beginning. So I have 4 PhD students. They're all working in different topics. Similarly, I have 4 master's students. The good thing is, I mean, there's one good thing, and I look at these names, and one bad thing is, well, the good thing is that I have people from all over India. So Orko is from Calcutta, Sushil and Ajay are from UP, Biju and Anil, they are from Tamil Nadu and Andhra, Kisla is from Delhi, Harsh is from Rajasthan, Kurat is from Srinagar. So I have from all east, west, north, south. So I'm very happy that group is well covered. Why? But one thing I feel bad about is that I have only one female candidate or female student. So I would like to work on it. It's in my mind. And I would also tell you that now even the funding agencies are looking at it. So recently I was yesterday reading a Twitter handle. So where the scientists told that she got a very good review for her proposal. It was 100 out of 100, but she didn't get the fund. Someone else got. The reason was that she had, I think, 9 female students and 4 male students. So she had not good gender balance in her group. The other competitor had better balance in terms of gender representation, and that's why the competitor got the grant. So we have to be, I mean, not just because of grant, but we have to be careful that we have to give representation to 50% of our I mean, in our world, 50% of females roughly. So we have to have that representation there in every sphere of life. And since I'm here, I've been giving talks here and there. So once I got an invitation to give a talk in another group in our department, then I was giving a talk in Bangalore. So my alma mater, there was a conference on tribology. And for the first time in my research career, I got an award for best speaker in India Trib 2019. And I am continuing with my sports activity. So now I am playing badminton, but thanks to the COVID, I'm not playing it anymore right now. But yeah, I've started running again. I stopped running in Germany because of injury, but now I've slowly started it again. So with this, I would just say one more thing, that what I've understood in my various travel and everything, and I found out in this was someone pointed out to me that it is there in the Vedas as well. So the education is the best education, and nobody can take it away from you. So don't worry that just share it. If you share it, it will increase more. So don't be like, try to be a team player. I mean, if you know something, you share with others, and you learn always from others as well. Don't think that you know something and it will stay with you, or you can keep it with you. Better you share it, you learn from the others, your team members and everyone. You should share your knowledge. With this, I'll stop. Thank you. And that was one of my holy pictures from Zurich. And my email ID, if you want to contact, you have anything to ask about any of the places I have been to, anything you want to know about any of the subject I'm studying, or anything you want, any information you want. Another thing I would like to tell you guys that the Indians are very good in this social networking, but I've of late noticed that Twitter is very good for academic work as well. I mean, they're all the best of the scientists in the world on the Twitter, all the major journals. So all my, I mean, academic knowledge, I get many things. I mean, informations I get from the Twitter. So, I mean, I know that it's very politically very active place as well. So you don't have to follow those people. Just follow academician, and you'll get to know many more opportunities and what is happening in the world. Thanks a lot. With this, I'll stop.
Thank you, sir. It was a wonderful speech and it was very inspiring. You've brought in new concepts such as tribology and all. I've never heard of that. And you also gave us some tips to lead life, like to get involved in sports, to have many options in life. And more importantly, the most inspiring line from your speech was your decisions is important because it's the one which makes it unique. And then time management and efficiency, everything was awesome, sir. Thank you for your wonderful and inspiring speech.
Thanks. Thanks a lot.
And
Yeah,
now,
yeah. Thanks, Nomita, for summing up the talk. And it was really nice talk. Dr. Manjesh, it's absolutely fantastic, and I'm really impressed with your career, a journey, that has been shared by many of the ex-participants of the YSL, as well as you and me, Dr. Nitin, and myself. We are actually educated from Malayalam. I mean, myself, I am from Malayalam medium schools, throughout my life, and then I shifted to English in +1 and +2. So exactly just like your trajectory that we have taken, Dr. Nitin has been educated in Hindi medium, just like you. So there is actually a misconception in India that let us send our students to English medium school because there is a supremacy, English supremacy that guys. I mean, we have to actually hear. The youngsters should hear our story, the life story. It's not nothing to do with the language, but the perseverance for learning, and also your ending slide on Vedas is fantastic. Love for knowledge is amazing. And yeah, your overall, the talk was absolutely fantastic. It's absolutely one of the best talks I can easily say in the YSL series. And yeah, and there is a lot of binding as well. You were talking about water as a lubricant. I was just thinking about my own experience in Antarctica. I was actually part of the Indian Antarctic mission 2 years back, and as you see, the glaciers are also a kind of there's a friction going below the glaciers. It's something like the water. Of course, water as a lubricant. I was just thinking about it. Glacier movement on the ice sheet is exactly just that. There is a proof of water being a lubricant, and that is, I think, that connects the interest of Naumika and your talk. You see, seemingly entirely different. The remote sensing or geoinformatics, and how mechanical engineering is coming in picture. The rheology and the tribology, very interesting field, exciting. I was completely yeah, I was actually enjoying your talk, to be honest. Yes, thanks, Manjesh.
Thanks a lot.
Over to Dr. Nitin. Nitin is also here with us now.
Yeah, thank you so much, Dr. Manjesh, for sharing your journey, and your talk was very informative, and it was very simple, and you have shared your research experience in a simple ways, so that all of can understand in a easy manner. So I want to read one quote that push yourself because no one else is going to do it for you. And you started from a humble background, studied in Hindi medium, as Dr. Felix mentioned, and motivated by family members to study engineering. You did a PhD and postdoc from abroad, and now placed in esteemed institute in India, which is IIT. It shows your dedication, determination, and hard work. I congratulate you for this success and achievements. And yes, I can say that you are doing an interesting and important research in the area of soft matter, tribology, and rheology. So thank you once again for your wonderful talk. Over to you, Dr. Felix.
Yes, Naumika, you can start the questions. You can pick up the first question in the pool, or if you want to get some answers from him, you can pose your own questions too. Yeah, go ahead.
You've been very long in sports, right? So how has sports transformed your life?
I'm not a sports person. I do sports just for relaxation. So, I mean, what I would say that so if I go for a sports in the morning, I feel fresh. I can work very well. If I don't do it, then I feel that something is missing in my daily life. And also when I take break, I mean, when I go for sports, I mean from my studies and all. So it gives me time to think, or like delink myself first from my work, and then think freshly. So another thing is good health, which is very important. I know many scientists who are not able to do as much as they could have done because of the health condition at the very young age. So I mean, it has multiple. I mean, it has all the positivities, no negativity. So I would always encourage, and this, as I told, my cousin first brought me into this thing that you should. I used to walk a lot. He told me you should run. You are young, And then I saw my PhD supervisor. He would run for 5-10 kilometers easily. He came to Germany to give a talk in my institute. We were out to a restaurant for lunch, and we were like some 4 or 5 kilometers away. And he asked me, "Can we walk?" I said, "Yeah, I'm fine." He walked. So he taught me that you have to enjoy your life. You don't stop living because you're doing science or something. You have to maintain a good balance. You have to do both of them. So that's what I can say.
Yes, sir. Thank you, sir.
Yeah, so just just connecting to that line. So yes, so sports, of course, it's not really sports. Running should be part of our own lifestyle. Everybody, I would rather say, I'm almost a kind of a part-time runner. So weekly twice I go for a running. So running is kind of like, and there are studies that shows that if you actually do the aerobic exercise, your memory retention is also quite high. And when I was in Germany, I've seen that the Western Europeans, they actually run quite a lot, right, in the park and all that. That's I see that it's missing here. The running is it's taught like a profession here, a kind of a sports. But that is not the case in West or in Japan as well. People actually run because it's part of a normal lifestyle. So I think that we have to actually change our style also. The part. If you look at the evolution, we have been running for all these years, running, escaping from the predators. So we have to go back in those old days, isn't it? What do you think? So Manjesh, you did your PhD from ETH and a postdoc many years in Germany. What is your experience with intercultural or cross-cultural communication? According to you, what is the best thing you learned by interacting with the people from different countries? You actually interacted. You said that you had friends from Australia, everywhere, right, around the world.
Yeah.
So what exactly, do you advise the youngsters to go abroad for a PhD or a postdoc, or rather confined in India only?
No, I would not say that whether you should go or you should not go, but if you get opportunity, you should travel. And you should talk to people. So I can tell you two short stories. One was, I was told in my school. It was not a story kind, it was an incident. So, I was in class 4, I remember this incident very well. And we had this, like all of us had this value education course. So we will read some inspiring Hindi stories in the last class, just before the leave bell goes off, and we will all look around because we want to go home. And then we had one of this class, and someone was reading a story and everybody has to listen. And then we saw outside, our teacher told us, don't listen to what he's saying, look outside, observe, you will learn more. What we saw, that somebody just threw away some rice or something for the birds to eat. So there were few birds who were eating and few were fighting. They wanted to grab it more. So he told us that, look at them. Those who are fighting, they're not getting anything. Those are eating quietly, they're getting their food. So that's what, the lesson he told us, that you have to observe around you. And that then you will learn much more than by reading books. So that was one. And about cross-cultural experience. So basically I observe, when I'm talking, I'm observing and listening to what they're saying. And cross-cultural thing, I can tell you one incident. So I had one French colleague who came once with me in India. And we went around in Kerala, Munnar and all these regions. And we had elephant ride and all. And he also stayed with my family. So I have family members in Bangalore. So when he went to have, I think lunch he was having, and he started eating with spoon. So one of my family member told him that his name is, his name was Nicola. So they told him that in India we don't use spoon. So he started eating with hand without any problem. And then only we two were going around. There was no one else. And we stayed in different restaurant or hotel for food. And I saw him like taking chapatis with just hand breaking and eating it. I told him, you don't have to do it. There's no one to observe you. He said, no. When you are in Rome, you behave like Romans. So that was an eye-opening for me, that I should also respect. If someone is saying that this is how we do. And if it's not harming me in any way, I should do it. I mean, I should not have any problem with doing it. So that was a big eye opener for me, that he will do, because he is in India. He will respect the local custom, and he will do the way people do it here. So that was one of my experience, which I can tell you. And of course, I mean, now I respect others' point of view, and I am open to listen to others more than if I would have been just here, perhaps.
Yeah, I heard an aphorism. I don't know who coined this aphorism. It says that traveling is the best cure for racism. You know, if you travel and if you interact with other people, then you can never be a racist. So I agree with you, your point of view as well. Yes, you know, we have to entertain the different point of view. So I think that's a very important hallmark of traveling as such. Over to Dr. Nitin. Would you like to ask a question?
Yeah. So Dr. Minal Batra is asking, please tell us more about polymer brush, how it's used in human body. So and please give some takeaway lessons.
So as I showed you in one of the slides, that on our body, like all the joints, we have these glycoproteins, which are like what I was saying, polymer brushes, like polymers grafted from one end. So basically, there's glycoproteins grafted on our surface between opposite surfaces, and this synovial fluid is in between. So polymer on its own will not give you good lubrication. You have to have good solvent for the polymer. So you may have hydrophilic or hydrophobic polymers. And what it does is that, I mean, I don't know if I'm visible. So if you have polymers on both sides, because of entropic reasons, it will not allow interdesitation. So you'll always have some gap in between, which will be filled by the liquid, the fluid, the water, or whatever fluid you have. And when you apply shear, so this polymers take the normal load, and this, if you have a low viscosity fluid in between, it will shear easily. So you get very, very low viscosity. So that's what I mean. And we get this problem of knee. I mean, you will see now in old age, we have all sorts of problem. This is basically your joints are basically drying. When you have dried contacts, then you start to get more and more friction.
Thank you. Over to Naumika. You can ask question.
So there's a question from Silpi Sarkar. Can biopolymers be checked for its characterizations, such as toughness, viscosity, and interaction? If so, what are the techniques?
I mean, why not? You can use just normal mechanical. I mean, you can do normal mechanical things, or people are using AFM, colloidal probe based AFM. You can use them for mechanical testing easily. You can do all sorts of tests with the AFM on the polymers. Biopolymers. We know like in bio people, they do this adhesion testing and all, or the toughness testing or mechanical testing at what load it will rupture. So AFM is a very good technique.
Yeah, I want to add on this because I have worked on the biopolymer production from macroalgae, seaweeds. So there are several physicochemical characterization is there if you want to characterize the biopolymers. So like as Dr. Manjesh mentioned that you can use AFM, then apart from that you can use a TGA, DSC, you know, just for the characterization. There are some tests if it depends on the type of application you want to use that biopolymers. For example, if you want to use it for as a food packaging application, then you have to do certain tests like oxygen permeability test, then tensile strength is important, so characterization is depend on the type of application you want to use that biopolymers.
Yeah, so I would like to add on a point. It's not adding on, but you have briefly touched on the synovial fluid. That's also an interjection of biology and mechanical engineering, and especially your tribology, right? Tribology, rheology is about the flow of matter, isn't it? Very interesting. So that kind of intersections are always interesting. So synovial fluid is, of course, is a natural, and now we have got prosthetics, the knee replacement. So is there any of your role or tribology role in the prosthetic, the lubricants? Is there any work on going on those lines? So of course they need to have a lubricants. Yeah, over to you.
So now you will see many of the companies in US are getting sued because people are living for longer time in West. So if you had a replacement, suppose hip replacement or something, transplant, so at 60 or 55, 60, 65 years of age, and 15, 20 years later, you are getting into trouble. The reason being that normally they have a coating, something like polymer brushes, which will do two things. It will avoid these proteins attacking or getting attached to the surface. So, and the other thing is that it gives low friction. But what happens, suppose over a period of time, this coating will wear off. And then you have all sorts of, I don't know the biology, so I may not be using the wrong term. So there's all sorts of attack. Like the body thinks that it's something foreign material there, which is actually a foreign material. But since the time you have a coating, a protective coating, it is protected. But when it wears off, you have all sorts of things getting attacking there, and you are in pain and trouble. And that's why now there are a lot of work in this direction of using polymer brushes and different kind of coating to increase the durability as well of the coating, not just to reduce the friction, but increase the durability as well. Because we are living, I'm told by my advisor once that now in Germany, for for girl child, they are charging or calculating the health insurance premium, assuming that the person would live for 100 years.
Oh.
So you have to make this replacement and all more and more durable, because if inside your body they go bad, then you are in big trouble. And if you search for Google for the news, you will find many news report where companies are getting sued by the patients who had replacement 5, 10, 15 years back.
Yeah, this AI inspired decisions are really, it's an ethical question now, especially for the life policies. The premium is much higher for the male than the females. So because of much higher for the females than the males, because the females live much longer life insurance policies. But on the other hand, if you come to the driving, for example, the car accidents are much more higher for the males than the females. So male end up paying a lot more than the female. So yeah, that's amazing. That talk is endless. So now coming to the lubricants. There is actually a very interesting product. There are a lot of products in the market. This is one of the product I love. I've been using for a long time, WD-40 by 3M. So, is there any interesting this kind of consumer products, the lubricant product developed from India? Can you name something which is, which is actually hit up the market and some new technology? I'm not saying like the old kind of things, but new one. Because there are a lot of developments in materials research as well, right?
Yeah, so I don't know, in terms of lubricants, I can say that IOCL has its own, this Castrol or something lubricant. This is an IOCL lubricant. IOCL has a big R&D facility in Faridabad. So where they do research, they have a big section in tribology. So where they do research. So, when I was in master, so my master project was funded by Tata Steel. And my professor had funding from all these big oil companies, this IOCL, BPCL, HPCL, because all of them have their own lubricants. And then we have some of the, we have a very good tribometer manufacturing company now in India. So it's in Bangalore. It was also initiated or like inspired from my master thesis supervisor, Professor Biswas. He's no more. So he kind of was one of the inspiration to start that company. It's called Ducom. So they are now competing with the global companies or global manufacturers in terms of tribometers or characterizing instrument or setup. And I can tell you one more in ETH. When I was in ETH, so all this Swiss watch. So there also you want long durability. So you want very ultra low friction. So I remember my professor once got a project where this, I think Swatch, they were funding, they wanted to have a coating which will give them lifetime lubrication. So it will not wear off and a very low friction. Typologies, I mean, everywhere. I mean, tire industry, everything. But lubricant-wise, I know Castrol. Other than that, I don't know any. I mean, something which was developed in lab and commercial, it's available. I don't know. I know, like in Europe, I know that where they go for skiing and all. So on the pad, and there tribology there. I mean, there are materials which are designed for tribological applications. When you're running, your shoes, bottom, your tire, everything is all tribology. It's just that we don't.
Well, yeah. Yeah, well, I just can't stop myself from quoting this example as well. This is from NASA. I think NASA has developed some kind of a special lubricant, and this has now found an entirely different application as a personal lubricant. It's Astroglide. I think the company is called Astroglide. I mean, cross, the discipline applications are always fascinating, isn't it?
I mean, even this famous NASA plane crash, where this lady, I think I forgot the name, the astronaut Chawla, what's the name? She died. She passed away in this NASA when the satellite was coming back. That was tribology.
Yes,
That was because of
Colombia.
yeah, that was because of friction that it burned down.
I see.
It crashed. It was again tribology.
All right. So because we are already, the time is already over, so I'm going to Naumika. So you can say a few words.
Yes, sir. Actually, the talks conducted by YSL are so inspiring. They bring up a spark in us to take up a career in science in all ways, in all fields like mechanical engineering, biotech, and genomics, and all. It was very useful, sir. More than that, we could get a scope for a life. And I thank all the people behind this team, Dr. Felix, Dr. Nitin Trivedi, and the speaker of today, Dr. Manjesh K. Singh. Thank you very much. And thank you for this opportunity.
Thanks a lot to everyone. Thanks for the opportunity provided.
Yeah,
Enjoy.
Dr. Manjesh, before concluding this session, I would like to ask one question. As you did your PhD and postdoc from abroad, and you are working in the area of this soft matter rheology and tribology. If, as most of the students, and researcher, if they want to pursue the research in this field in India, which are the best institution, if you can say something?
So almost IISc, of course, IITs. I mean, if you ask, because tribology and there's one problem, there are not many people who do both tribology and rheology. I mean, I don't know anybody, to be frank. So, but tribology is there in IISc. Now I am here. Delhi has a big tribology center. Then Kharagpur has tribology. I mean, tribology is now in many of the, because after I returned and during this COVID, I gave 3 or 4 talks, and it's well spread in many of the, I'm also surprised, but when it comes to soft matter, we have, I mean, we have very, very good groups. I mean, right from IISc and it's an interdisciplinary thing. So physics, chemistry, chemical engineering, mechanical engineering. If you go to IISc, you have people in physics, in chemistry, in chemical, in mechanical. In our IIT Kanpur as well is the same thing. We have in almost mechanical, chemical, physics, chemistry. We have people doing soft matters. In almost all the IITs and TIFR, ISERs. I mean, soft matter is, it's a very vast field, and we have very, very good groups. And there's a conference called Complex Fluid, ComFlu it is called. It is organized every year. This time it was supposed to be in Gandhinagar. It's normally in December. Last time it was in Isaac Bhopal. It's an excellent conference. So if you want to know all the people who are working in soft matter, you may attend this conference. And for tribology, again, we have this India Trip conference and Tribology Society of India. You can get a lot of information from there. But I can go for forever because there are so many groups I know. So it's very difficult to say exactly which one I would recommend.
Yeah, thank you so much. And I suggest and I request all of the students who want to pursue the career in this field, they can directly contact Dr. Manjesh for the guidance. So thank you once again, Dr. Manjesh, for interesting talk, and I wish you all the best for your future endeavors.
Thanks a lot. Thanks a
Yeah,
lot.
Dr. Manjesh, it was really nice. And just want to add before leaving to the Dr. Nitin's point, would you recommend any book, the textbook, if the students would like to read more about these two fields, the rheology and tribology? So, which textbook will you recommend?
Tribology, I can recommend this Introduction to Tribology. I may have this book here. No, I don't have it right now. Maybe it's in my room. So it's introduction. No, I have it here. Just a minute. So it's a good book for tribology. Introduction to Tribology by Bharat Bhushan. He was in Ohio State. I don't know where is it right now. So he's a very big name in tribology. Then there are other books as well. If you want to do it in short, see right now that book around me. But yeah, this is a good book, Introduction to Tribology. And for rheology, I cannot, because rheology I have not done much. I did just in my postdoc. So I have interest there. And I would like to continue working there, but I have been mostly doing tribology and soft matters.
So if you just say like in a very plain sentence, what is exactly the difference between these two fields, the rheology and tribology? It looks like quite identical, non-Newtonian soft matter flow, isn't it?
No, so the difference is that in tribology, you have, if you look at the definition, I said surfaces under relative motion. So you have surfaces involved. So in rheology, you have bulk, you have flow behavior of material, but bulk. So viscosity, what we study in rheology, but it's a bulk behavior. It's a material property. But tribology is not a material property, it's a system behavior. So tribology cannot say that steel's coefficient of friction is so and so, because you have to say steel against what, in what environment, what was the lubricant used, what was the temperature, anything. But viscosity, you can say, is a material property. But friction, you cannot say that this material has this much friction. You have to, it's a system behavior.
So would you say like rheology as a subdiscipline of fluid dynamics?
I mean, rheologists will kill me if I say so, but yeah, I mean, fluid dynamics is very vast. You can say rheology kind of, you can maybe say it, I'm not sure. But rheology is a, quite developed field. But yeah, it's basically viscosity and flow behavior and all these things.
Yeah, fantastic. Thank you so much for coming with us, Dr. Manjesh. And yeah, it was really a nice talk. Thanks a lot.
Thanks a lot.
And over to Dr. Nitin, so you can introduce our next speaker.
Yeah, so our next speaker in today's evening session is Dr. Yatindra Kumar from Indian Institute of Toxicology Research, which is a CSI laboratory, and he is working as a scientist in R&D and planning department. So see you at 4:30, and that will be going to an interesting session too. So please join at 4:30.
Yeah, till then, goodbye. Enjoy your Sunday.